If your metric says better, but users say worse, don't trust the metric, debug it. I'll show concrete sanity checks and slices that catch the common NDCG failure modes. You notice a new ranker scores higher on NDCG, but support tickets spike or engagement drops. That gap feels like betrayal. By the end of this video, you will know fast sanity checks to run in Python, interpret what they mean, and build a tiny slice routing plan so production serves the actually better model. These are quick, practical checks you can add to any evaluation pipeline. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Search evaluation lives between development and user impact. People use NDCG because it summarizes ranked relevance into one number, and it weights top results more. It solves the problem of comparing rankers across queries, but the downside is subtle. A single aggregate can hide that one query or one slice is getting much worse. Compared to looking at top one accuracy or user clicks, NDCG compresses a lot of behavior into one scalar. So you need checks that unpack it. Think of NDCG as a scoreboard for rank lists. It rewards putting highly relevant items near the top and discounts lower positions. Imagine a query with one perfect result and several mediocre ones. A ranker that always gets the perfect result right but shuffles the rest can still score high, even if users only care about the very top link. That intuition is why we run targeted sanity checks. Tiny NDCG examples, top one comparisons, traffic weighted averages, and cutoff sensitivity. We will use the same tiny corpus and 5 example queries throughout, so your mental model stays stable. The code will be short and illustrative, not a production pipeline. We will build 3 things: small NDCG checks, a comparison between NDCG and top one relevance, and a slice router that picks the better ranker per query mix. You will finish with a plan to add these checks to your CI. Now we build the first anchor test. This snippet computes a tiny NDCG3 on one query to anchor expectations. This snippet creates a single example query with a ground truth relevance list and 2 candidate rankings, then computes normalized discounted cumulative gain at 3 to show how small differences in order change the score. The goal is to make the metric feel concrete. If you change the cutoff from 3 to 1, the score will emphasize only the top result and may flip which ranker wins. This tiny test helps you calibrate what a meaningful score delta looks like in your context. Next, we contrast overall ranking score with top result truth. This snippet contrasts NDCG with top one relevance to catch misleading improvements. This snippet computes NDCG for each query and also checks whether the top-ranked item is actually relevant. Then reports mismatches where NDCG improves but top one relevance drops. The idea is simple. If users click the first link most, top one tells a direct story. Changing the threshold for what counts as relevant will change how many mismatches you see, and using stricter relevance makes the test harsher. This contrast surfaces rankers that win on deeper relevance but lose on the single most visible result. Now we look at query-level aggregation and traffic. This snippet shows macro versus traffic-weighted NDCG, revealing query mix sensitivity. This snippet computes per query NDCG and then aggregates it 2 ways: simple macro average and traffic-weighted average using a synthetic query frequency column. The walkthrough reveals how a ranker can look better when rare queries improve, but lose on frequent queries that drive most traffic. If you change the traffic weights, the weighted aggregate will move proportionally. So this test helps decide whether your evaluation should reflect query popularity or treat queries equally. Next, we probe cutoff choices explicitly. This snippet tests cutoff sensitivity by comparing NDCG at 1 and NDCG at 3 winners. This snippet computes NDCG at 1 and at 3, and then checks which ranker wins under each cutoff. The result shows cutoff sensitivity when one model places the correct result at the very top, while another distributes relevance across the top 3. Adjusting the cutoff up makes the metric care about more tail positions, which can advantage models that surface many moderately relevant items. Running both cutoffs prevents decisions based on a single arbitrarily chosen depth. Finally, we make a tiny routing decision plan. This snippet builds a tiny slice routing plan that picks the better ranker. This snippet groups queries into slices based on simple rules. For example, query length or click frequency, computes per slice metrics, and then selects the ranker that wins in each slice. The result is a tiny routing map that says solve ranker A for short, high-traffic queries and ranker B for long, exploratory queries. If you change the slice definition or minimum slice size, the routing recommendations will change. So pick slices that balance statistical significance with operational simplicity. Recap in 3 lines. What it is: a set of sanity checks for NDCG that expose common blind spots. When to use it: whenever a new ranker raises aggregate NDCG or before a production rollout. One caveat: these checks are small samples and heuristics, not a substitute for live experiment metrics. Next step: extend this approach by scaling your slices and adding timing and online A/B tests, or tune a key parameter like BM25, K1, and B if you use that ranker, to see how sensitive winners remain. If short practical IR helps, subscribe and watch the other IR videos.